So as you are aware of IPv4 address, IPv4 is a 32-bit address, but uh, there is a limitation of IPv4 addresses because nowadays we are using IP in each and every devices. So it is not possible from 32-bit addresses, IPv4 addresses, to fulfill the current requirement. Earlier, when it was developed, nobody knows that it will be too popular that we will use IPv4 to that extent that we do not have addresses, because right now if we will focusing on the countries which is having larger population like China, India, or any big country where each person is having a mobile phone, at least each person is having a mobile phone. Now smart devices are connecting with IP addresses. So we cannot fulfill this with this IPv4, we cannot fulfill this requirement. So this IPv6 comes into picture. So as in IPv4, it is a 32-bit address, whereas IPv6 is having 1 to 8 bits. 1 to 8 bits means, if you will just, I will zoom it. 1 to at 32 bits provides these many IP addresses. 2 ki power 32 means this much. Okay, so now this IPv6 is having 128 bits, so we can this is the addresses in IPv6. We can have these much addresses. So right now if we provide a everyone on the person who is alive, then also we can have roughly 50 octillion addresses per person. So it is a so right now after we can use it up to 100 years from right now. Okay, so it is very it is having a large addresses. Oh, what is difference between hexadecimal and this binary? Normally we write in binary. In hexadecimal, what happens, from 0 to 9, the numbering is same. From 9 to 10, when we this is the decimal, this is the binary, and in hexadecimal we write it A. Similarly, for 15 we will write F. So it is using from 0 to 15 bits. So in hexadecimal we will see the numbers from 0, numerical number will be from 0 to 9, and for 10 we will use this alphabet, that is A, similarly B, C, D, and E and F. So this is the representation, how we represent hexadecimal number. So as I told you that it is having 128 bit. So what happens in IPv6? IPv6 is made of 128 bit divided into 8 16 bits blocks. Each blocks is then converted into 4-digit hexadecimal number separated by colons, symbols. So we write, this is example of a IPv6 address. Here you can see 1, 2, 3, 4, 5, 6, 7, 8. There are 8. These are the eight blocks. Okay, 1, 2, 3,
So
4. Yeah,
so we can say it has 8 blocks
yes.
as compared to
Uh,
the 4 octets in IP version 4.
IPv4. So in
Right.
IPv4, each block contains 8 bit. Here each blocks contains 16 bit. So it is having, because a number denoted by in hexadecimal we denote the number, the binary equivalent is, you can see this is the 4 bit. So one hexadecimal number takes 4 bits. So each block will have 4 into 4 means 16 bit block. 16 plus 16 or 16 into 8, it will be 128. Okay, so if we will move further, then there are some certain rules which you can follow so that it will be very easy to because it is a large address. If you follow some rules, you can sort that address. So you can shorten that address. So to that to do if you do not want to write this much long, if you want to have some shortcut, so you can apply these rules. First is discard leading zeros. If it is having leading zeros, then if you is focus on block number 5, 1, 2, 3, 4, 5, this, okay, it is having 0, 0, 6, 3. Okay, so we can write it, what we can do, we can discard this 0, 0, which is starting. Okay, so we can discard the leading zeros. So we can write it from 0, 0, 6, 3, we can write it only 6, 3. Second rule is that if two or more blocks contains consecutive zeros, omit them and then replace with double colon sign. Means if you can see, this is having two blocks, is having all bits are 0. So what you can do, instead of writing these 8 bits, okay, 8 means this is, yeah, these much bits, you can, what you can do, you can just type is double colon. Okay, so if you will, you can write this, so our address will reduce from this to this. Okay, if you will focus on 6 and 7, 6 and 7 blocks are having zeros only, so we can write it by double colon.
One question.
Yeah.
Yeah, so if we had two blocks with zeros,
Yeah.
but if you have 3 consecutive blocks or 4 consecutive blocks,
Okay.
you can just put the colon and that will be understood.
Yes, you can.
Okay.
If continuously, if there is a continuously 0, you can write colon.
Right.
But there is third rule for your question. Consecutive blocks of 0 can be replaced only once by double colon. So if there is still blocks of 0 in the address, then you can shrink down to single 0. Means if you are having a means this is here, it is 0, 0, and this is 0, 0 here also. So what we can do, we can write this 0, only a single. In second, we will write a single. We can use that thing only once. Okay. So this will be the our final. We can reduce this address from this to, from this we have taken this one, and we can write it in short. We can write it this, because it is having 128 bits, so it will be longer address. So if you will apply these rules also, then also it will be if you compare it with IPv4, then also it will having more numbers. So now we will discuss about network and node address. Okay, IPv4 and address is split into two components. One is called network component, and other is called this other is called uh, subnet mask, or the host portions. We divide it into network portion and host or node component. IPv6 also we split that into two parts. We It is a 38 128 bit address. So what we do, we divided it into 64 into 64 bits. This is used for network and this is used for node. The upper 64 bits are used for routing. The lower 64 bits identify the address of interface or node and is derived from actual physical or MAC address using IEEE EUI 64 format. Means 34 bits will be fixed. It will be having the upper 64 bits are used for routing, whereas lower you can each, means it will be after 64 you can give the host addresses. So either you can type your addresses, or as you are saying that it is you are saying that in few of your devices it is automatically configured. So it is automatically configured with the use of this also MAC address using IEEE EUI 64 format. If you look into the upper 64 bits in more details, we can split it into two blocks of 48 bits and 64 and 16 bits. So if we are focusing on this upper 64 bits, so this will be 48 bits. This will be used as a unique global addresses, where this 16 bits we can do subnetting, as we can do subnetting with only this 16 bits. As in IPv4, whatever host portion we are having, we can do subnetting for that. But here we can do subnetting with this 16 bits only. Okay. So what is this EUI 64 format? Actually, the MAC address of a system is composed of 48 bits, and it's represented in hexadecimal. Whenever you see your computer NIC card MAC address, then you will find it in hexadecimal. There will be some uh, numerical and alphabet also. So it will be in alpha numerical format. So normally if it is having 64 bits, so first 24 bits identifies the unique, it is for the unique identification of that company who is manufacturing your card. Means if you are using some card of Cisco, then it will be having some specific, these bits for Cisco will be reserved. Or if you are using some gigabit or some vendor, Dell or some other PC or some vendor NIC card, then these bits will be especially allotted for that organization. So for all in whatever card you are using with Dell, it will having all will having the same this organization in MAC address. These for 24 bit will be fixed. Whereas these bits, if suppose Dell is manufacturing first laptop, then they can configure it 00001. Then they will increase it by 1, 2, 3. So similarly, in so this way, each MAC address is unique, because firstly, what it will do, if you are using a Dell PC, then if you are using a HP PC, so HP will manufacturing its network card with its organization code. So there will be uniqueness between HP and Dell from this first 24 bit. And inside that Dell, if you are using two PC of Dell, then the first 24 bit will be same, but these bits will have different. So with the use of this NIC card, we can whenever anybody wants to track, if you are doing some activity and if anybody want to monitor you, so it will track your IP address, then it will say see what is the NIC card or MAC address which is bind with that IP, so it can reach to up to you. So this is the this way, this we can change our IP address. You are using a PC, you can change PC of that IP address, because you can change that. But NIC, that card, it is a hard coded, so you cannot change that one. So this is the basic structure of a MAC address in a card. So with, as it is a unique, so in IPv6 they use this uniqueness of this card while conferring this automatic IP address, that is we called it EUI 64 format. So what is do, it divides, it insert a bit, a 24. What it do, first a host divided its own MAC addresses into two 24 bits halves. Then 16-bit hexadecimal OXFFFE sandwiches into these two MAC addresses. Means here we will insert these two bits. Okay, 16 bits, we will insert this FFFE. This bit we will insert inside that whatever MAC address you are having. Then what we will do? Yeah.
Question?
Yes, yes.
Right. Okay. So as it stands now, devices like the NIC,
Hmm.
they are designed with the 48-bit MAC addressing scheme, right?
48-bit. Yeah.
Right. Now, as they came up with IP version 6,
Mm-hmm.
is it that eventually, or is your or they already have uh, um, components like NICs with the EU E64 design, or they still using the 48-bit design for the NICs?
No, I do not get your question. Please, can you come
Okay,
again? Yeah.
let's say again. Okay. The NIC that is being manufactured now,
Yeah.
they are using the 48-bit MAC address on NICs right now, right?
Yeah.
Good. Now, IP version 6 is
Yeah.
out. Are
Yeah.
manufacturers going to be using the EUI64 to create MAC addresses for NICs, or they will remain with the original design for
No,
NICs?
no, they are using in the same format, because this is they they will design with the 48 bits. This they will design whatever they were designing earlier. They are using the same format, but
Okay,
what we are discussing here, in IPv4, to auto configure your address whenever you connect your PC. And in IPv4 also you get one address, 169 range address automatically, if you are not using DNS also. Or if you if you want to auto configure that thing, for that purpose this EUI64 format is taking help of your uniqueness of your MAC addresses. So these things will be same. Right now also you will have 48 bits MAC address card inside your PC, but in IPv4 it is taking the advantage of this uniqueness. So what it is doing, it is inserting how it is calculating that address. This is the there is no this stepwise step, this will be not process. Only I have mentioned this so that I can tell you how this EUI64 format comes, or how they calculate
understood.
EUI format. So they take
Understood.
this 48 bits, divided into 24 bit and 24 bit, and insert this FFFE bits inside between these. So this will be like they will sandwich these bits in between these two parts. Then what they will do, they will just take seventh bit. Seventh bit means this is 00. Seventh bit means 00 means this is a binary hexadecimal number. So 4 bit, 4 bit. If you will calculate the 7 bit, it is 0. Then it will convert the 7 bit into 1. Okay. So if it is a 0, then they will convert it into 1. If it is a 1, they will convert it into 1 into 0. So they will just reverse that bit, 7 bit. Okay. Then this will be 02. Now this will be the final your EUI format address, IPv6 address. Okay. We will see this later on. But how EUI64 format is calculated, it is based on uniqueness of your MAC address. So what it do, it just take your MAC address, it divides into two parts and inserted that bit. And then on from your MAC address, it will just convert your 7 bit into, it will just reverse that bit. If it is a 0, it will convert into 1, and 1 it will convert into 0. So as here it is 0, so it will convert it into 1. Then this is the final EUI format which is going to assign automatically to your computer. Okay. You can also give you a computer your IP address, same way as you are doing with IPv4. You are going to your means, if you want to assign something, you will just go to your network console, and then you will provide the addresses. You will just go there and you will give the address. Same way you can assign with your this with, with your IPv6 also, you can assign that thing. Okay. You can just click on IPv6, then you can configure your IPv6. Just I will show you. So as we are using IPv4, now we will take IPv6, then we can use this thing. Okay. And we can if you we can use this obtain an IPv6 address automatically also. So we will just we are focusing on concept, we will do practical also, so it will be clear. So how many address types are there in IPv6? There are three types of addresses. One is unicast address. Second is anycast address. Third is multicast address. But as in IPv4, there is a broadcast address. But IPv6 does not have a broadcast address, and multicast address took over it. So when we will discussing these things, it will be clear. So unicast address means unicast address identify a single interfaces. Anycast addresses identify a set of interfaces in such a way that a packet sent to anycast address is delivered to member of sets. Multicast address identify a group of interfaces in such a way that a packet sent to a multicast address is delivered to all of the interfaces in that group. So these three types of addresses we are having in IPv6. So firstly, we will discuss about unicast addresses. So in unicast, if you will see more on unicast, if you will focus on unicast address, then you can divide this address into three types. One is global unicast address. This unicast address is equivalent to IPv6, IPv4 public address, as we are using public addresses. There also, you are aware that there are two types of addresses there. One is private and one is public in IPv4 also. So there is some 10 range is reserved for from each class A, class B, and class C. We have some private address reserved, which we have discussed when we have discussed IPv4. So in IPv6 also similarly, there are global unicast address. These are the public addresses, not private addresses. So you can use this on internet. These addresses equivalent to IPv4 public addresses. Global unicast address in IPv6 are globally identified and unique level addressable. So uniquely addressable means you can give uniquely. It will be only if you purchase this from some ISP, then only you are going to use that one. Nobody others in the world will use that address. These addresses are assigned by INA and used on public networks. They have a prefix of, so this will be the all addresses that begins with binary 001, or they have a prefix of 200 colon colon slash 3. So this will be prefix, or you will have in all global address, you will have this prefix. Okay, so this is 48 bits. If we see, if we focus on this 128 bit, this is the global routing prefix, 48 bits. This is the subnet ID, and this is the interface ID, where we will for host portion we will use this one. Okay, so unique, second one is unique local. This is the second type of unicast addresses. Similar to IPv4 private addresses, these are used in private networks and aren't routable on the internet. These addresses have prefix of FD00, this one. So this is same way as we are using for private. If you want to use inside your organization, you can use a private addresses within your organization, so that you need not to purchase many public addresses. So you can use, anybody in his organization can use these private addresses as similar as with IPv4. So these types of IPv6 is globally address is globally unique, but it should be used in local communication. The second half of the address contains interface ID, and the first half divides into prefix, local bits, global bits, and subnet bits. So this is the this if it is starting from this, so it is a unique local address. And third one is link local. These addresses are used for sending packets over local subnet. Routers do not forward these packets with this address to other subnets. IPv4 requires a link local address to be assigned to every network interfaces on which the IPv4 v6 protocol is enabled. These addresses have a prefix of FE80 double colon, and this is the subnet CIDR format, so it is /10. Auto configured IPv6 address is also known as link local address. This address always start with FE80. The first 16 bits of link local address is always set to this. Okay, the next 48 bits are set to 0. So this is the link address, link local address. So this will be link local address. Whenever you are using this, we will just with this figure you can just you can whatever we have discussed. This is global unicast address, unique local address, and link local address. So it is having link local scope, it is having organization site scope, and it is having global scope. So the scope of link local address is limited to the segment. Okay, for a particular segment, it will be limited to that segment only. Means if you are using your PC and you are connecting it, so if you are getting a automatic, you are getting 169 pool addresses. Same way, this is a local, in a local segment you can do. But if you want to use it in your organization, you must use unique local addresses. And if you want to go for this global, then you can use that global unicast addresses. So unique local addresses are locally global but are not routable over internet, limiting their scope to organization boundary. So you can use within your organization and anybody else can use that thing inside that organization. Global unicast addresses are globally unique and recognizable. They shall make a sense of internet version 2 addressing. So this is the basic thing of about IPv6. So if just if we want to sum up, so we have discussed what is different between IPv6 and IPv4. In IPv6 we are having 128 bit addresses. It is in hexadecimal format, so it is divided into 8 blocks, each having 16 bits. There are some rules by which you can you can you can you can just shorten your IPv6 address. You can discard leading zero. If two or more blocks contain continuous zero, you can just write double colon. But after writing a double colon, if still there is some zero, so you can write a single zero there. So if you are having two or more blocks, means if we are having this address, if we are having this fe0 fefb, if here we are having 0000, or this is having 0000, so we can write for two or more block, we can just write this double colon sign. Okay, so but this should be continuous. Means we have not this is not continuous. Okay, so there are some on bits available in between this block and this block, so we cannot write double colon here. So we can use double colon here, but here what we can do, according to rule 3, we can write a single zero here. So then we have discussed the IP. What is the format of IPv6 addressing? It is having 128 bit. Out of these, 64 bits are used for network and 64 bits are used for node. Then this is the structure. We can do subnetting on this 16 bit portion only. Okay, so then we have discussed UI64 format. This is the alternate if you just do not want to type a IP address, or if you can use your MAC address. It will automatically, it will be calculated. You need not to just type something. You need to just when we will configure, we will discuss this point. So it will be auto configurable your this IPv6 addresses with the use of this format. Or you can type simply, you can type your IPv6 address. And then we have discussed the address types. We are having three types of address: unicast address, anycast address, and multicast address. There is no broadcast address available. Unicast address further divided into three parts: one is global unicast, another is unique local, and last one is link local. So it is similar. If you want to use in a local segment, you can use link local ISCO, this link local addresses. If you want to use within your organization, you can use unique local addresses. These both addresses are not routable, so you cannot use outside your organization. But if you want to use outside your organization or in internet, you must use this global unicast addresses. So this
Uh,
was the, yeah, you
what?
can ask any
Yeah,
question. Yeah.
yeah, sure. Yeah. I'm just looking at. So I just wanted to clarify. The unique local address
Hmm.
is it would be referring to the ones that are within your LAN, not those that go onto the internet.
Yeah, within your organization you can use it. Means it should not go to, you can use if you are using a, if you are taking a unique local address and you are doing subnetting and you are using some routers inside your organization, you can use it. But it should not go it will be a it will have conflict if you are using it in over internet, or it should not
Right.
go in public domain.
Okay. Okay. And the link local address
Yeah,
is referring to the segment within your LAN.
yeah.
Right.
You
Okay.
can use only a single segment. You can use this link local address. Okay.
Right. All right.
So on next class now, what we will do, we will configure these addresses so it will be clear, and we will also do subnetting, IPv6 subnetting in next class. Okay.
Okay, cool.
Okay.
Yeah, that was very extensive. I
Yeah.
must say, you went into a deep dive with the IP version 6. Thank you for that.
Okay. Thank you. So we will